So, hello. So, welcome friends. This is our third session of vibration rotation spectra of rigid diatomic rotor or vibrating rotor. Okay. So, I request you to watch our previous two sessions of this session. Now, we are entering in third sessions. In previous session we have derived these equations. The sum of the vibrational and the rotational energy is given by the Born-Oppenheimer approximation, and we have derived this equation delta epsilon Vj is equal to V prime minus V double prime epsilon omega bar plus B J prime minus J double prime, okay, into square bracket J prime plus J double prime plus 1. Okay. So, in this session we will learn the selection rules for vibration rotation spectra. So, we have two rules, delta V is equal to plus minus 1 and delta J is equal to plus minus 1. Now, for delta V is equal to plus 1, okay, it means that V prime minus V double prime is equal to 1. Now, what is V prime and what is V double prime? Okay, look at the spectral diagram. So, this is a spectral diagram. This is the lower vibrational energy level and this is the upper vibrational energy level. In these two vibrational energy level, okay, there are n number of rotational energy levels. Again, next vibrational level will be here. There are again n number of the rotational energy level. So, in the second part and first part, we have seen that whenever a molecule interacts with infrared radiation, then vibrational transition will takes place. Okay, and when this vibrational transition takes place, then along with this transition rotational transition will also takes place. Why? Because the vibrational energy is larger than the rotational energy that we have seen in the previous lecture. If this concept is not clear, then please watch previous session, part 2 session and part 1 session. So, this V double prime stands for the lower vibrational energy and this P prime stands for the higher vibrational energy levels. Now, these are the rotational energy level between the lower vibrational energy level. So, it is shown by the symbol J double prime. So, lower rotational energy levels in lower vibrational energy levels. These are the higher rotational energy level J prime in the higher vibrational energy level. Okay. So, difference between this V prime minus V double prime is equal to here V prime minus V double prime is equal to 1. Okay. Now, let us put this value in this equation which we have derived. So, therefore, V prime minus V double prime is equal to 1. So, therefore, we get delta epsilon Vj is equal to omega bar plus B J prime minus J double prime into J prime plus J double prime plus 1. This is, let us say, this is equation number 4. Okay. Now, let us put the case number 1. Okay. Delta J is equal to plus 1 and delta J equal to minus 1. Why I have written is that because selection rule for this vibrating rotor is delta V equal to plus minus 1 and delta J is equal to plus minus 1. Okay. Now, let us assume, consider the case 1, delta J is equal to plus 1 means J prime minus J double prime is equal to 1. Okay. J prime minus J double prime is equal to 1. Now, you take this J double prime to the left hand side, then we get J prime is equal to J prime plus 1. Okay. Now, let us put this value J prime value in equation 4. Okay. I will put now this J prime value in equation 4, then putting the value of J prime in equation 4, we get, therefore, okay, delta epsilon Vj is equal to omega bar B into, okay, let us put this value of J prime. So, what is value of J prime? J prime plus 1, J double prime plus 1. I have put this value here, then this J prime value is J double prime plus 1. Okay. Now, simplify this. J double prime minus J double prime, it will cancel out. So, what is remaining is 1. Then j double prime plus j double prime equal to 2. 1 plus 1 is equal to 2. So 2j double prime plus 2. Now take 2 common, okay, outside of this bracket. Then final equation we will get delta epsilon Vj is equal to omega bar plus 2b j prime plus 1. Okay, so this will gives us the given spectral line. The energy of spectral line in centimeter inverse is given by this equation. Okay, now let us put the value of j double prime. What is j double prime? It is a rotational quantum number whose value starts from 0, 1, 2, 3 and so on. Okay, so when j double prime is equal to 0, then our mu spectral line or transition will be, how to read this? Okay, this is the spectral transition from j double prime 0 to j prime. Okay, j double prime 0 to j prime 1, which is equal to omega bar plus 2b. Okay, let us put the j prime value is 0 here, then 0 plus 1 is 1, so it will be 2b. Okay, next j double prime is equal to 1. Put this j double prime value is here 1, so 1 plus 1 is equal to 2 into 2 is 4. So next value, spectral line value is omega bar plus 4b, then next it will be the 6b centimeter inverse and so on, which you can calculate. Okay, now let us go to the case number 2. What is case number 2? Delta j equal to minus 1, that is j prime minus j double prime is equal to minus 1. Look at carefully. Okay, here delta j equal to plus 1, it means that difference between upper rotational energy level and rotational energy level is equal to plus 1, difference is equal to minus 1. Okay, how it is, I will explain you. So now take this j prime to the right hand side, then we get j double prime is equal to j prime plus 1. Now what we will do, we will put this equation in equation 4 like this. Okay, sorry, here equation 4. Now you need to put the value of j double prime and you need to simplify that. Okay, so putting value of equation, putting this value in equation 4, then we get omega bar b j prime. Okay, what is value of j double prime? It is j prime plus 1. Okay, this is the value, and here again j prime plus 1. Okay, simplify this, then j prime minus j prime, it will cancel out, remaining is minus 1 here, and here 2j prime plus 2. Take 2 common, then we get final equation, the mu spectral line, energy of mu spectral line equal to delta epsilon Vj is equal to omega bar minus 2b j prime plus 1. Now put the value of j prime is equal to 0, then we get the spectral line at omega bar minus 2b, j prime is equal to 1, then omega bar minus 4b and minus 6b and so on, that you can calculate. Okay, now let us understand the spectral diagram. Okay, so this is the spectral diagram, and which shows transitions between rotational vibrational levels of a diatomic molecules. Now look at here. Okay, this is, I have explained you, this is the lower vibrational energy level and this one is the upper vibrational energy level, or it is called as higher vibrational energy level V prime and lower vibrational energy level V double prime. Now we have seen already that this is our vibrational transition. This is our vibrational transition and it is taking place from phi prime, phi double prime to the phi prime. Okay, delta phi is equal to plus 1. Okay, now when this vibrational transition takes place, then there are n number of rotational transition also takes place and it will give us a complex spectra. Now this vibrational line will be observed here. Okay, this is my vibrational line and its energy will be in centimeter inverse, will be omega bar. Okay, this is the fundamental vibrational frequency I observed here. Okay, now look at here. So for the first transition, okay, for transition bit from j double prime 0 to j prime equal to 1, we will do that. Okay, now we will give the numbering to this. Okay, let us give the numbering. I will rub it. So it will be simpler for us. J double prime is equal to 0, 1, 2, 3, 4. Okay, here J prime equal to 0, 1, 2, 3, 4 and 5 and so on. Okay, so I will little adjust the camera. Yes. Okay, now so look at this transition, the transition from the first transition here. Okay, this transition here. So J prime 0 to J equal to 1. Okay, here. So this transition, okay, this is the first transition and the first line is observed at here. Okay, so the value of this first line is equal to how much? Just we have calculated, omega bar plus 2b. Okay, second transition will be from J double prime equal to 1 to J double prime equal to 2. Okay, this is second line which is observed at, this is a 2b, this is a 4b. Third line is observed at J double prime 2 to J prime 3, J prime 3, and third line observed is here. Okay, this is 6b. Similarly, fourth line will be J double prime 3 to J double prime 4. Okay, this will be what? 8b. Okay, now come to the case number 2. Delta J equal to minus 1, transition from J double prime 1 to J prime 0. Okay, here. Okay, J double prime 1 to J prime 0. Okay, this transition. Okay, so 0 minus 1 is equal to minus 1. Okay, so this is this transition. Delta J is equal to J prime minus J double prime. So J prime is 0 minus J double prime is equal to minus 1. So delta J equal to minus 1. In this way the value is given. So the value is, this is first rotational line, this is what? 2b, omega bar minus 2b. Then second transition will be from 2 to 1, third 3 to 2, fourth 4 to 3. Okay, this is the 4b, this is third line, 6b, then 8b. Okay, so this is the increase energy in centimeter in mass. So now the naming, how these lines are identified. This is the fundamental vibrational line, this is the first rotational line observed at lower side. So the name is given is P. So these lines are called as P branch lines. Okay, the line on this lower side of fundamental vibrational frequency is called as P branch lines, and these lines which are observed at higher wave number side is called as R branch lines. Okay, now numbering, let us give the numbering. Okay, this is the R. Okay, it starts from 0, R1, R2, R3 and so on. Okay, this is first line. P, transition takes place from 1, P1, then P2, P3, P4 and so on. Okay, so this is the vibrational spectra for the rotating vibrator or oscillating vibrator of our diatomic molecule in gaseous phase. Okay, so here we will conclude our sessions. So this is our third video of rotation vibrational spectrum of rotating vibrator or oscillating vibrator. So I request you, please watch these 3 videos, part 1, part 2 and part 3 again and again till you get all your concept clear. Okay, So thank you for watching the video. If you have any difficulty, then please WhatsApp me or you can call me. Okay. So thank you. See you. Bye bye.